Good morning, my dear students. Now we are going to talk about solutions. What is the solution? Solution is a homogeneous mixture of two or more substances which do not chemically react to each other. Listen. Solution is a homogeneous mixture of two or more substances which do not chemically react to each other. This is homogeneous mixture. This is heterogeneous mixtures. Water with sugar. This is homogeneous mixture. This is water with sand, not homogeneous mixture. This is heterogeneous mixture. Types of solutions. An unsaturated solution is a solution in which most solute can be dissolved at a given temperature. A saturated solution is a solution containing the maximum amount of solute that will dissolve at a given temperature. A supersaturated solution is a solution that contains more solute that would dissolve in a saturated solution at a given temperature. Types of solution: gaseous solution and liquid solution, solid solutions. Solute and solvent and examples: solute, gas and gas, mixture of oxygen and nitrogen, and liquid and gas, example chloroform mixed with nitrogen gas, and solid and gas and camphor in nitrogen gas, and liquid solution gas, liquid and oxygen dissolved in water, liquid ethanol dissolved in water, solid liquid glucose dissolved in water. Solid solution: gas solid, solution of hydrogen in palladium, liquid solid amalgam of mercury with sodium, and solid copper dissolved in gold. What is the solute and what is the solvent? A solution consists of a liquid with a substance dissolved in it. A solution consists of a liquid is called the solvent, with a substance dissolved in it is called solute. A solubility: that amount of solute which can be dissolved in a solvent. What is the molarity? Molarity is also known as molar concentration. It is defined as the number of moles of a solute dissolved in 1 liter of a solution. Is mole per liter or molar? Say cap cm. Molarity equal to weight of solute divided by molecular weight of solute into 1000. What's the molality? Molality is the concentration of the solution expressed in mole of solute per kilogram of solvent. In symbol small m, it is units or moles of solute kilogram per solvent, and is written as 1,000 m NaOH for a 1 molar concentration solution of sodium hydroxide. Molarity equal to moles of solute divided by moles of solvent. Next one, normality. The normality of a solution represents the number of equivalents of solute contained 1 liter of the solution. Normality equal to number of gram equivalents divided by volume of solution in liters. Next one, formality. Formality is symbol caps F is the number of formula weight units of solute per liter of solution. The purpose of formality is to distinguish the number of moles of a compound from the number of moles of ions in solution of ionic compounds of weak electrolytes. Next one, mole fraction. It's important to my question. It's the ratio of number of moles of a particular component to the total number of moles of all the components in the solution. If a substance A dissolved in substance B and the number of moles are Na and Nb, Na means number of A and number of B respectively, then the mole fractions of A and B are given as mole fraction of A equal to number of moles of A divided by number of moles of solution, Na divided by Na plus Nb. Mole fraction of B same, Nb divided by Na plus Nb. Mass percentage. The mass percentage of a solution component is defined the ratio of the component mass to the solution's mass expressed of the percentage. Mass percentage equal to mass of component and divided by mass of solution into 100. and concentration of mass. Chemists express concept of an unsaturated solution of a mass solute dissolved per volume of solution. 1 liter equal to 1000 milliliter. This is concentration of mass or volume. This volume percent. This volume percentage or percent. Mass of solute dissolved in a volume of solution expressed as a this symbol volume or mass percent volume of solute divided by volume of solution into 100. Next one, parts per million, ppm. Parts per million is grams of solute per million grams of total solution. ppm equal to mass of solute divided by mass of solution into 10 to the power 6. Next one, standard solution. A standard solution one that we know the exact concentration of they are used in a volumetric analysis to help us calculate the concentration of another solution. Therefore, we must be certain of the concentration of the our standard. Only certain chemicals can be used in the production of standard solution. Advantage of using standard solution. The error in weighing the solute can be minimized by using concentrated stock solutions that requires large quantity of solute, which can prepare working standards of different concentrations by diluting the stock solution, which is more expensive since concentration is maintained. Some of the concentrated solutions are more stable and less likely to support microbial growth than working standards in the experiments. Solubility of solute. Let's take again solubility of solute. Solubility of solute is the maximum amount of solute that can be dissolved in a specific amount of solvent at a specified temperature. It's a very important point. The maximum amount of solute that can be dissolved in a specific amount of solvent at a specific temperature. Solubility of a solute is the maximum amount of solute that can be dissolved in a specific amount of solvent at a specified temperature. It's a very important Henry's law. The solubility of a gas in a liquid is directly proportional to the partial pressure of a gas present above the surface of a liquid or solution. Dalton said the mole fraction of gas in the solution is proportional to the partial pressure of the gas over the solution. The most commonly used form of Henry's law states that the partial pressure of the gas in vapor phase small b is proportional to the mole fraction of the gas x in the solution and as kh is a Henry law constant. Limitation of Henry laws. 3 mark question. Henry's laws, it applies closely to gases with nearly ideal behavior at moderate temperature and pressure. If the solubility of the gas in the solvent is low, if the gas does not react with solvent to form a new species, thus ammonia, which react with water, does not obey Henry's law. NH3 plus H2O to form NHO plus and plus OH minus. Fourth one, if the gas does not associate or dissociate or dissolving in the solvent. Next one, Rowler's law. The common mathematical statements of the behavior is known as Rowler's law. P solution and X solvent and P solvent. P solution is the observed vapor pressure of the solution. X solvent is the mole fraction. P solvent is the vapor pressure of the pure solvent. What is the evaporation and what is the condensation? Generally, liquids have the tendency to evaporate if the kinetic of molecules in the liquid state overcomes the intermolecular force of attraction between them. Then the molecules will escape from the liquid state. The process is called evaporations. Listen, the kinetic of the energy of the molecules in the liquid state overcomes the intermolecular force of attraction between them. Then the molecules will escape from the liquid state. The process is called evaporation. If the evaporation is carried out of a closed container, then the vapor remains in contact with the surface of the liquid. These vapor molecules are in continuous random motion during which they collide with each other also with the walls of the container as the coalescing inelastic. They lose the energy as the result the vapor returns back to liquid state. The process is called condensation. What's the ideal solution? What is the non-ideal solution? Ideal solution. A solution said to be ideal if it strictly obeys Raoult's law at all concentration and temperature. For example, obeys Raoult's law, does not obey non-ideal solution. First one ideal solution example benzene and toluene and N-hexane and N-heptane. Non-ideal solution. Solution which fails to fulfill the characteristics of an ideal solution are known as non-ideal solution. Ethanol and water and nitric acid and water. Difference between Henry's law and Raoult's law. Henry's law is a thermodynamic law that explains the dissolution of a gas in a liquid medium. And Raoult's law is a thermodynamic law that explains the relationship between the vapor pressure of a solution and the partial pressure of solution in the solution. Says the amount of gas is dissolved in a liquid in directly proportional to the partial pressure of the gas that is equilibrium with the liquid. Says that the vapor pressure of a solvent above the solution is equal to the vapor pressure of the pure solvent multiplied by the mole fraction of the solvent. And Henry's law, the proportional constant in Henry's law, this is called Henry's law of constant. Raoult's law does not use proportionally constant. Dear students, watch this video 2 or 3 times so that you can understand the concept well. Today's homework question: define Henry's law and define Raoult's law and define molarity and normal train. Here I give 3 questions for you, so you have think and answer and study and write 3 times on your homework note and test your home test note. Take a photocopy and send it my personal WhatsApp number. Thank you, students. God bless you all.